Last week, we flashed Micropython on a Wemos D1, but typing out our application code every boot isn't exactly useful. So let's fix that. When you write code in Arduino, it is compiled and combined with the firmware before flashing onto your microcontroller. However, with Micropython, you flash what is effectively an empty operating system. Then you need to load your code onto the microcontroller separately. In a sign of what is Micropython's immaturity, the entire instruction section on this process is a total of 2 paragraphs that doesn't actually tell you how to load files. It directs you to using WebREPL, which isn't enabled by default, and I personally find extremely annoying to use. So this week, I'm going to show you how to load files onto the Wemos D1 Mini using a tool called Ampy. This tool was originally written by Adafruit, and I hacked it slightly to work with the D1. So on to business. As usual, we have prerequisites to address. The first is to install the modified version of Ampy. You'll want to run easy install with the URL shown both on screen and in the description. My modifications to the original library are minimal, just enough to get functionality with the D1, and that's the only ESP8266 chip I've tested with. If you're working with another, it may work, or you might try the original copy of Ampy by Adafruit, which is also linked. They have code tuned to work best with Adafruit hardware. The second prereq isn't a hard requirement. It is a small repository of sample Micropython code that I'm working on and use as a demo in this video. So if you want to follow along with exactly what I'm doing, you'll need to either clone the repository or download the zip file from GitHub's website. The final item of preparation is to plug in our Wemos D1 and verify we know what port it is running on. Just like last week, run ls-dev-cu* and keep that information handy. Adafruit Micropython tool, or Ampy, is a utility that allows you to list, get, put, and delete files on the file system of a Micropython controller. It uses command style similar to that of FTP. So the first thing we're going to do is run Ampy with our port and ls, which Mac and Linux users will recognize as directory listing. Hopefully you will see output similar to what is shown on screen. Now I'm a lazy programmer and I don't want to type the port information over and over. So I'm going to export this environmental variable of Ampy port that will allow us to skip typing that device every time. We're running Ampy ls again, but this time without the port explicitly set. As expected, it shows the same output as before. As we have seen, the Micropython file system comes with 2 default files, that of boot.py and main.py. Boot.py, as the name implies, is run first on both power-up and resets. It should contain low-level code that sets up the board to finish booting, but typically isn't something you will need to touch until your projects get much more advanced. Main.py is executed automatically after boot.py and is where we will put our application code. Using ampy get boot.py, we can see the default boot file, which is good enough, and main.py is blank. Now that we've gotten the contents of a file, let's finally put our own application in place. I'm in the Micropython sample code directory from the second prerequisite. The code in blink.py is the same hello world code we used last week, so let's load that. Run ampy put blink.py main.py. The first file name is what is on our computer, and the second is where on the microcontroller the file will be uploaded. So we're overwriting the currently blank main.py on the Wemos D1. At first nothing happens because the code isn't running yet, but we can use ampy reset to soft reset the device, which will then start main.py. While I'm quite sure the code is written to the device, let's prove it the old-fashioned way. I'll unplug the D1 from my computer and plug it into this lithium iron phosphate battery, which happens to provide just about exactly the right voltage for an ESP8266 without needing a voltage regulator. As you can see, our very complicated blinking application is running. At this point, we have a totally standalone controller running Micropython code, but I want to show you one more useful feature of Ampy before we go. I won't bore you with showing how ampy-del removes a file, but I will show you how we can use ampy run slowblink to execute a different application. You'll notice that I didn't transfer it to the controller in advance. This is very handy for development when you want to write code on your computer, then immediately run it on the Wemos D1. Unless you reset or power cycle the D1, it will keep running this new code. In this respect, development on Micropython is certainly much faster than Arduino, where you would need to recompile and reflash for every single code change. So there you have it. We can now save and run our custom code on the Wemos D1 without using the REPL. If you happen to load bad code onto the controller and lock it up, just erase and reflash the firmware. I certainly had to do that a few times while figuring out this process. If you got anything specific for the Wemos D1 you want me to try, let me know in the comments below. I've got a few projects in the works, like the BME280 I mentioned last week, but I'd be happy to add more to the docket. Lastly, I wanted to thank viewers for the likes, subscribes, and comments last week. I was really surprised how many people found the first video interesting or useful. So with that, hopefully we'll be back next week, and hack a great day.